We'll be learning here how to derive formulae, physical formulae, using the method of dimensions. Now we'll learn this using a simple example of a simple pendulum. Now a simple pendulum is a small mass suspended using a thread from a point and then given a little horizontal push, and then it starts to oscillate. Now for such a pendulum, we know that the time period of oscillation is dependent on the length L of the pendulum and the acceleration due to gravity. Now we'll be trying to determine the exact nature of this dependence, and so we assume that the time period t is directly proportional to the length L raised to the power a and acceleration due to gravity g raised to the power b. It is the value of a and b that we have to determine, and once we have the value, we'll know the relation between t, L and g. Now this is a proportionality, and therefore to convert it into an equality, we introduce a constant of proportionality c. And now as of now our result is t is equal to constant c into length L to the power a and acceleration due to gravity g to the power b. Now the dimensions on both sides of a correct physical equation have to be same. So the dimensions of t, which should be same as dimensions of time, should be same as dimensions of the right hand side of the equation. Now on the right hand side we have length raised to the power a, so L to the power a, and acceleration due to gravity g to the power b. So acceleration has dimensions L t minus 2 raised to the power b. So on the left hand side we have dimensions m to the power 0, L to the power 0, t to the power 1. And on the right hand side we have no mass, so m to the power 0, L to the power a plus b, because we have L to the power a into L to the power b. As per rules of indices, powers are added, and so we have L to the power a plus b and t to the power minus 2b. Now comparing the dimensions on both sides, remember the dimensions have to be same on both sides of a correct physical equation. So m has a power 0 here, m has a power 0 here, no issues. L has a power 0 here, L has the power a plus b here, which basically means that a plus b should be equal to 0. Only then the dimensions can be identical on both sides. So a plus b equals 0, and minus 2b has to be equal to 1 here, because the power of t on the left hand side is 1 and the power of t on the right hand side is minus 2b, and therefore minus 2b equals 1 and a plus b equals 0. The power of L has to be same on both sides, a plus b is 0, power of t has to be same on both sides, so minus 2b is 1. We now have two equations involving two unknown quantities. Such simple linear equations can be easily solved. We get b equals minus 1 by 2 and a equals plus 1 by 2, which leads us to the formula t is equal to some constant into root of L by g. Physically we know that this formula for time period of a simple pendulum is t equals 2 pi root L by g. So in place of c, the correct physical formula has 2 pi. Now unfortunately, using this method of dimensions, this constant cannot be determined. The method also has certain other drawbacks. There are certain things you cannot really do using dimensions. For instance, if you have those functions which are dimensionless, any physical formula involving dimensionless kind of functions, for example, formulae that involve trigonometric functions or exponential functions, they cannot be derived. Also, formulae which involve addition or subtraction cannot be derived. For instance, the displacement equal to ut plus half at square, that formula cannot be derived using dimensions because it involves a addition. So any formulae where addition or subtraction is involved cannot be derived. Constants cannot be calculated. Also, here we had a dependence on two quantities. So we had two unknowns a and b. If the dependence is on a larger number of quantities, you may end up with more variables than equations. You may end up with more unknowns than equations. And in those cases, you cannot solve using dimensions as well. So the process has certain drawbacks, and the biggest drawback of all is that you have to know the dependence first. That t depends on L and G has to be known before we can make this derivation, which basically brings you to using physical methods. And using physical methods anyway we can derive these results. But then this process is useful because often we can determine, once we get to know experimentally the dependence of t on L and G, the nature of dependence can be known a little bit more precisely before even trying any physical methods. So while it has drawbacks, it has its utility as well. Thank you.